Okay, class, welcome to our next video lesson. We are still examining the scientific view of the nature of matter. That is our main standard that we've been studying. In this particular lesson, we're going to be looking at the periodic table of elements. We want to be able to recognize that there are more than 100 elements and some have similar properties as shown on the periodic table of elements. First, let's look at a little history of the periodic table of elements. The periodic table was first published by Dmitri Mendeleev in 1869. Now, although there were other scientists before him that made very valuable discoveries towards this periodic table, he is the one that is given the sole credit for the development of it. But when Mendeleev was putting his table together, he did use a lot of the discoveries that had already been made by Antoine Lavoisier and John Newlands. So they were also scientists who contributed to the periodic table of elements. All right, this is one of the early periodic tables that Mendeleev discovered and actually published. This one was done in March of 1869. And we're going to, as we dive deeper into this lesson, we're going to talk about why does he have some of these elements in rows together? Why are some of them in columns together? There is a purpose for Mendeleev having put the table together in this manner. Now, this is the modern day periodic table of elements, which you are familiar with. It's pretty much seen just about in any science classroom in the world. The periodic table of elements is universal. So this is the same table that they would use over in other countries. So this is a very universal tool that we see everywhere. Well, let's look at this periodic table and talk a little bit about how it's set up. First of all, how are the elements on the periodic table organized? Elements on the table are organized by their properties. And when we say properties, we mean what are some characteristics of these elements? And once scientists were able to figure out characteristics of the elements, they were able to group them according to these similar properties. On the table, you have rows and you have columns that represent relationships between the elements. So they didn't just take the elements and just stick them in various locations on the table. There was a method to this. And if you notice back on the previous slide at Mendeleev's table, he had certain elements in certain columns and rows together. And it's because of the similarities that they had. The rows on the table are what we call periods. The columns are what we call groups. The elements in each group have similar properties related to their structure. What are the three categories of elements found on the periodic table? When you look at the periodic table, there are three main categories of elements that you have. There are metals, metalloids, and nonmetals. Now, all of these different classes or categories of elements, they have similar properties. So we're going to go back to the modern day periodic table in just a few minutes and just kind of look at how you can see, well, all of these elements that are over here are metals. All of these are nonmetals. And then you have one little small group that are what we call metalloids. Metals generally have a shiny luster and are good conductors of heat and electricity. You will notice when we go back to the previous slide that the metal class or category is the largest category of elements on the periodic table. Nonmetals are usually dull in appearance. And metalloids are elements that have characteristics of metals and nonmetals. So metalloids would kind of be like if you had a bond between metal and nonmetals, then their babies would be the metalloids, that they have characteristics of both. But let's go back to the modern day periodic table. And if you look here, all the elements that exist on the far left side of the table are what we call our metals, okay? That includes this group down here, which are called transition metals. And these metals down here, they sometimes can have some unique properties. That's why they're kind of off in a block by themselves, but they're still considered metals. Over here, to the far right of the screen, is where you're going to have your nonmetals. Now, there is a small group of elements in the middle, which is what we call our metalloids. And it starts right here. There is a stair-step line that these elements make going all the way down. And any elements that touch this particular line are what we would call our metalloids. Okay, it's not many of them, but we start right here at boron with this line, and we go all the way down. You make like little stair steps going down, and that is what we call our metalloids. Okay, remember the metalloids are the ones that have a characteristics of metals and nonmetals. Well, that concludes our lesson on the periodic table of elements.